Okay, so for question number 1, is it a conservation of energy question? Nope. It's a work energy theorem question. I just put it in there to see if you read it carefully and figured it out. Okay, so we have a small cart with a mass of 1.5 kilograms. It's traveling at 3 meters per second initially. A force acts on it that we don't know, causing it to accelerate to 9 meters per second. Okay, and we're looking here for how much work is done. All right, so work is a change in energy. In this case, it's which kind? Kinetic. All right, so give them 1 mark for that and 1 mark for their givens. Do I need to use force and distance here? I don't. Okay, they didn't give me force. They didn't give me distance either, so there's no way for me to use that. But I can find the change in kinetic energy because I have the mass of the object and the 2 speeds that it is moving at. All right, so I'm just going to say that work equals 1/2 mvf squared minus 1/2 mvi squared. They can have a mark for that. Okay, plugging in our numbers, that'll be 1/2 times 1.5 times 9 squared minus 1/2 times 1.5 times 3 squared. Okay, they can have a mark for that. And that will give us our final answer. So 1.5 times 0.5 times 9 squared, okay, minus 0.5 times 1.5 times 9. All right, so how much work is done? 54 joules. Fifth and final mark on that one. You can have, we'll give them 1 here, but then we can't do it for the number plugging. All right. Any other questions on number 1? Okay, question number 2. Okay, so we have a roller coaster at the top of a 35-meter hill, traveling at an unknown speed. Later on the ride, the coaster is 12 meters off the ground, okay, and moving at a speed of 21.8 meters per second. All right, how fast was it going at the top of the hill? 1 mark for givens. Okay, since they don't mention anything about friction or air resistance, we can assume that all mechanical energy is conserved in this question. Okay, does it have both kinds of energy at the beginning and both kinds at the end? Yes, okay, so we're going to have, okay, EP initial plus EK initial equals EP final plus EK final. They can have a mark if they got something that looks like that. Okay, then we're going to expand that out. So M times G times H initial plus 1/2 MV initial squared equals, actually, sorry, before we do that, what we're looking for is part of the initial kinetic energy. So I want to get that by itself right now by subtracting the potential over. All right, so we got EK initial equals EP final plus EK final minus EP initial. All right, so if they've got that step, maybe it's not here, but maybe they've shown that they've done that somewhere else in their steps. Okay, we'll give them that as part of the manipulation marks. Okay, so at this point then we want to plug in our formulas. So we're going to have 1/2 MVI squared equals M times G times HF minus, or sorry, plus 1/2 MVF squared minus MGHI. All right, they can have a mark for that. So what are we up to now? 3. Okay, so now we need to manipulate in order to find the initial speed. Okay, I'm going to cancel off all the M's. I kind of have to because the question didn't tell me the mass of the roller coaster. Okay, and then I'm just going to divide both sides by 1/2, and then I'm going to square root. Okay, so what they should have for their next mark is that VI equals the square root of GHF plus 1/2 VF squared minus GHI divided by 1/2. Okay, so that's 4 marks now. No, that's 5 marks now. Okay, so when they plug in their numbers, it's going to look like this: 9.81 times 12 plus 1/2 times 21.8 squared minus 9.81 times 35 divided by 1/2. Okay, so that's kind of all 1 mark, whether they did it that way or not. Okay, and then we'll calculate VI by plugging that into our calculator. Okay, sorry, I'm not going to do it that way. 9.81 times 12, okay, plus 0.5 times 21.8 squared minus 9.81 times 35. Whoa. And then divide that by 1/2, and then square root. Okay, so initially it was moving at 4.9 meters per second. Okay, that'll be their 6th and final mark on that one. Quiz is out of 11, so give them a mark out of 11 at the top. Then I'd like them in a nice neat pile right here, please.